In sac323 number 1, we're given a potential energy function of position, x, y, z are the Cartesian coordinates in question. And we're asked, that's a comma there, we're asked to find the force exerted on the particle which has that potential energy function. The force in terms of the potential energy function is just the negative of the derivative of the potential energy function, and in particular we're actually getting a component of the force. The force is a vector and they want the component along the y direction, so it's the derivative with respect to y. The total force would be obtained by obtaining each of the components of the total force vector. So this is f sub y, and it's minus du by dy. Here's u itself. I'm going to write u as minus gm1m2 times the x squared plus y squared plus c squared, all to the minus 1/2. Find it easier to do derivatives if I get everything all on one line. So du by dy, let's say minus du by dy, is equal to minus this constant out front, and then times the derivative of this piece, which will be minus 1/2, times this quantity raised to the old power minus 1, which would be minus 3/2, and then by the chain rule for a function of a function times the derivative of the inside with respect to y, which will just be this piece will give us 0, that piece 0, this derivative with respect to y holding the other position variables, in this case x and z, constant. So that just gives us the 2y. Derivative of y squared is 2y. Bring down the power out front, and then multiply it times the y raised to the power reduced by 1. And what do we have here? The halves cancel, or the 2's cancel, I should say. And then minus, that's 3 of them, so we'll get a minus negative value for f sub y. I've got gm1m2y. I want to make sure that is clearly a 1, subscript 1, not a comma there. And then all times this x squared plus y squared plus c squared quantity to the minus 3/2, which is the same thing as the quantity in the denominator to the positive 3/2. And that'll be the component of the force in the y direction for exerted on this particle, whose potential energy function is given by this expression.